Hi everyone, so we're nearing the home stretch with talking about similar figures, and today we're going to be talking about the triangle proportionality theorem, aka the side splitter theorem. Now, we've actually been using this theorem since section 7.3 when we talked about triangle similarity, where we had overlapping triangles. The side splitter theorem is a way to do overlapping triangles without separating them. I preface that because you might not remember all these proportions. So separating the triangles will always work. And I want you to know that you can completely do this by separating the triangles, okay? But the side splitter theorem basically says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. So meaning if this is the line parallel to a side of a triangle, so this side, and it intersects the other two sides, so it intersects this side AC and side AD, then it divides the triangle proportionally, saying then that 24 over 10 would be equal to 12 over x. So that's actually very helpful. It allows me to actually see the proportion right away without having to separate the triangles. I'm sorry, my battery's about to die. So, okay, and then I can simplify. So this becomes, let's see, 2 goes into both, so that's going to be 12 over 5. So now we can see that x would have to be 5. Okay, now the triangle proportionality theorem does give us a proportion for EB and DC as well. This one's a little bit trickier though, okay? So that proportion, I said that this was X, and I said, I don't know, that this was 20, okay? Actually, let me make this Y. Y and 20. That proportion is slightly different, and why I always tell kids you really should probably separate the triangles, because it's the top of the triangle, or 12, top or 12, over the whole side of the triangle equals the middle of the triangle, that smaller parallel line, over the longer parallel line. So the proportion for that segment from the side splitter theorem would be 24 over 34, because you have to add 24 and 10, equals y over 20. All right, so you can absolutely do this, but it's one that can be a little bit tricky because you have to add the 24 and the 10. I could have done the same thing with the 12 and the 5, okay? All right, so I'm going to simplify. That's going to give me 12 over 17. Oh, I made this yucky, sorry. And then we're going to do the cross products, so that's going to give me 240 equals 17y, and then I'm going to divide by 17. And that gives me, let's see, 240 divided by 17, so 14.12. Okay, so again, the side splitter theorem is just called the triangle proportionality theorem. It's a way to write a proportion for the side lengths of a triangle in overlapping triangles when you don't want to redraw them, okay? All right, well now this one actually can get a little trickier when we reorient the figure. So let's use the side splitter theorem here to find y, okay? All right, so I see the parallel lines here. So my proportion would be CM over MB equals 10 over 6. So CM is 12 over Y equals 10 over 6. We simplify the proportion, or the ratios we can, so that would give me 5 over 3, and then we would do the cross products, so 5y equals 36, and then divide by 5, so y equals 7.2. So it's actually a nice way. This is one where you don't have to actually find the scale factor. You're just directly writing the proportion. Again, the side splitter theorem. All right, so the side splitter theorem actually can be extended to any time we have parallel lines that intersect transversals. So here's an example. We call it the corollary to the side splitter theorem. Here I have these three parallel lines. So let's mark them all parallel, okay? And they intersect two transversals. When that happens, it divides the transversals proportionally. So the proportion would be 2 over 8 equals x over 12. I can simplify 2 over 8 to 1 over 4. And then 4 times 3 equals 12. So I'm just going to use equal ratios here. And 1 times 3 would give me x, so x would be 3. This should kind of make sense to you that these are proportional. Like, look at that. They're not the same. They're proportional. And that's because the parallel lines aren't moving. So anything between them would actually have to have the same ratio. All right, I want you to try the next one, okay? All right, press pause, try it, and come back. Okay, so hopefully you pressed pause, you tried it, and here we are. So you wrote your proportion, 15 over 10 equals x over 12. You simplified this to 3/2. You saw that 2 times 6 gave you 12, so 3 times 6 would give you 18. All right, so let's take it one step further. Let's see if we can write the proportions for this figure at the right, okay? All right, so they gave me a over c, so they did a over c has to be equal to, hopefully you're seeing that would be d over f, because they have to be in between the same parallel lines. F over E would have to be, hopefully you see it, C over B. Okay? And then E over F would have to be B over C. You try the next three. Okay, this one's a little trickier. They did A over something equals B over E. You can remember the properties of proportions let you write this different. So if we do B over E, then it would be equal to A over D. Okay? That same proportion I can write a little differently. I can write A over B equals D over E. Same exact proportion. How can you always check if you cross products it, you should get the same thing. And look, AE equals BD, and look, AE equals BD. All right, so then we have F over C. Okay, F over C would have to be equal to E over B. All right, guys, that's video 1. Now you can head on to video 2. Have a great day.